This lecture is a brief introduction to the course. We're going to cover the objectives of the course, the prerequisites and course format, the reference books, and how to complete the course. The objectives of the course are the following. First, we would like to cover the basic concepts and practical techniques in text data mining. So this means we will not be able to cover some advanced techniques in detail, but rather we're going to choose the practically useful techniques and then treat them in more depth. We're going to also cover the basic concepts that are very useful for many applications. The second objective is to cover more general techniques for text data mining. So we emphasize the coverage of general techniques that can be applicable to any text in any natural language. We also hope these techniques to either automatically work on problems without any human effort or only requiring minimum human effort. So these criteria have helped us to choose techniques that can be applied to many applications. This is in contrast to some more detailed analysis of text data, particularly using natural language processing techniques. Now, such techniques are also very important, and they are indeed necessary for some of the applications where we would like to go in depth to understand text data in more detail. Such detailed understanding techniques, however, are generally not scalable, and they tend to require a lot of human effort. So they cannot be easily applied to any domain. So as you can imagine, in practice, it would be beneficial to combine both kinds of techniques, using the general techniques that we'll be covering in this course as a basis, and improve these techniques by using more human effort whenever it's appropriate. We also would like to provide a hands-on experience to you in multiple aspects. First, you're going to get some experience with using a text mining toolkit and implementing text mining algorithms. Second, you will have opportunity to experiment with some algorithms for text mining and analytics, to try them on some data sets and to understand how to do experiments. And finally, you will have opportunity to participate in a competition of a text-based prediction task. You expect to know the basic concepts of computer science, for example, data structures and some other really basic concepts in computer science. You also expect to be familiar with programming and comfortable with programming, particularly with C++. This course, however, is not about programming, so you are not expected to do a lot of coding, but we're going to give you a C++ toolkit that's fairly sophisticated, so you have to be comfortable with handling such a toolkit. And you may be asked to write a small amount of code. It's also useful if you know some concepts and techniques in probability and statistics, but it's not necessary. Knowing such knowledge would help you understand some of the algorithms in more depth. The format of the course is lectures plus quizzes that will be given to you in a regular basis. And there is also optional programming assignment. Now, we've made programming assignments optional, not because it's not important, but because we suspect that not all of you will have the needed computing resources to do the programming assignment. So naturally, we would encourage all of you to try to do the programming assignments if possible, as that would be a great way to learn about the knowledge that we teach in this course. There's no required reading for this course, but I also list some of the useful reference books here. So we expect you to be able to understand all the essential materials by just watching the lecture videos. And you should be able to answer all the quiz questions by just watching the videos. But it's always good to read additional books to enlarge the scope of knowledge. So here I listed 4 books. The first is a textbook about the statistical natural language processing. Some of the chapters listed here are especially relevant to this course. The second one is a textbook about information retrieval, but it has broadly covered a number of techniques that are really in the category of text mining techniques. So it's also useful because of that. The third book is actually a collection of survey articles, and it has broadly covered all the aspects of mining text data. The mostly relevant chapters are also listed here. And in these chapters, you can find some in-depth discussion of cutting-edge research on the topics that we discuss in this course. And the last one is actually a book that Xiang Messer and I are currently writing, and we are going to make the relevant draft chapters available at this URL listed here. You can also find additional reference books and other readings at the URL listed at the bottom. So finally, some information about how to complete the course. This information is also on the web. So I just briefly go over it. You can complete the course by earning one of the following badges. One is course achievement badge. To earn that, you have to have at least 70% average score on all the quizzes combined. It doesn't mean every quiz has to be 70% or better. The second badge listed here is a course mastery badge, and this just requires a higher score, 90% average score on all the quizzes. There are also 3 optional programming badges. I said earlier that we encourage you to do programming assignments, but they are not necessary, they are not required. The first is programming achievement badge. This is similar to the course achievement badge. Here we require you to get at least 70% average score on programming assignments. And similarly, the mastery badge is given to those who can score 90% average score or better. The last badge is a text mining competition leader badge, and this is given to those of you who do well in the competition task, and specifically we're planning to give the badge to the top 30% in the leaderboard.